Okay, next we will be talking about formal charge. And formal charge is really a way to figure out if a Lewis structure is good or not. Okay, so you might have multiple Lewis structures and you're not sure which one is correct. This is how you decide. So what we do is we compare a lone atom's electrons to the bonded atom's electrons. Okay, and if you don't really know what that means, that's okay. So let me give you the little equation that I never use. This is in the book, but formal charge, Fc, is equal to valence electrons minus 1/2 of the bonding electrons plus, well, I don't know why I put parentheses around that. 1/2 the bonding electrons plus the non-bonding. Electrons. Okay, and let's just talk about that real quick. Valence electrons are from the atom. Okay, that was terrible. Let me erase that. Can't write with a highlighter. Okay, these are from the atom. So the valence electrons for the lone atom. And then all of this, that is the atom in the molecule. All right, so let me give you an example. Let's say we have NO2, and we do the Lewis structure. Oh, that was wrong. N2O, sorry. N2O. NO2 is a much more common molecule. Anyway, so let's just say I asked 3 people to do the Lewis structure for N2O, and I get these 3 answers. Okay. N with a triple bond and a lone pair, nitrogen, single bonded oxygen, 3 lone pairs. Then I get this one, 2 lone pairs on this nitrogen, double bonded the central nitrogen, and then oxygen with a double bond. And I get also this one. Triple bonded oxygen there with a lone pair, and then this nitrogen on the end has 3 lone pairs. Now we look at that and we say, shoot, how do we decide which one is better? Okay. So let's first calculate the formal charges, and then we will go ahead and decide which one is better. Okay, so here's the way I like to do it. You can use that equation that I wrote up there. That's fine with me. Lots of different ways to do these things. So what I like to do is I pretend that I've broken this bond in half and broken this bond in half. Okay, I'm just going to do that to every single bond. I'm going to break them right in half. And when I break a bond in half the electrons go one way, half the electrons go the other way. So I'll show you what I mean. So let's calculate the formal charge for this nitrogen. Nitrogen always has 5 valence electrons. So that's the 5 valence electrons that nitrogen has all the time. Okay. I'm sorry. What I mean by that is if we look at the periodic table, nitrogen has 5 valence electrons as a lone atom. Okay. Now, what I do is I say there's 1, 2, 3 bonds plus 4, 5 lone electrons. So 5 minus 5. That gives me 0. Okay. So one way I heard this from a what do you call it? SI later was sticks and dots, okay? Valence electrons minus sticks and dots. So sticks are the bonds, dots are the lone pairs. So we'll do it again for this nitrogen. Nitrogen always has 5 valence electrons. And then we have 1, 2, 3, 4. 4 bonds. So that is 5 minus 4. Okay, and then for the oxygen, let's do that up here. Oxygen has 6 valence electrons, minus 1, 2, 3, 4, 5, 6, 7. That gives us a negative 1. Okay. Now, let's go on to the next one. Again, nitrogen 5 valence electrons. Actually, what would be a great idea is if you pause the video, see if you can get the formal charges on the rest of these elements. So go ahead and pause it and then come back and see if you got it correct. Okay, so this nitrogen 5 valence electrons minus 1, 2, 3, 4, 5, 6. That gives us a negative 1. Okay, this nitrogen here, 5 valence electrons minus 1, 2, 3, 4. That gives me a plus 1. And then the oxygen, oops, that was for that nitrogen there. That was for that. Got to keep everything straight. Oxygen always has 6 valence electrons. Minus 1, 2, 3, 4, 5, 6. That gives us 0. And moving on to this other nitrogen here. 5 valence electrons for nitrogen, again, minus 1, 2, 3, 4, 5, 6, 7. That equals negative 2. This nitrogen here, 5 minus 1, 2, 3, 4. That is a positive 1. And then finally, that oxygen on the end there. That is 6 minus 1, 2, 3, 4, 5. That's positive 1. Okay, so now we have the formal charges. We can go ahead and use them to evaluate which structure is better. So, some things to look out for. 1. Now I know how my grandma felt trying to use a mouse for the first time. Anyway, what we want is the smallest formal charge is always better. And when I say smallest, I really am talking about an absolute value. I don't care if it's positive or negative. Okay, smaller value is better. So one way to say that would be 0 is better than plus 1 or negative 1. Okay, and then 1 is better than 2. So let's just take a look at that and see if we can rule anything out right off the bat. Okay, so if we look at this first Lewis structure, we have 0, plus 1, negative, minus 1, minus 1, plus 1, 0. Okay, so those are kind of the same. We have zeros, we have plus 1s, we have minus 1s. This one here, we have a negative 2. Okay, so I know immediately because of that negative 2, this is not the right structure. Okay, so when you see a larger magnitude formal charge, you can immediately dismiss it. Next, we want, and there's really only 2 things. We want the negative formal charge on the most electronegative element. and that just gives us the most stable element. We're not going to talk about why any of these things are, it's just that they are, okay? So a negative formal charge on the most electronegative element, let's go back and look at that. Okay, so if we look at the two remaining Lewis structures, we have a -1 on an oxygen, and here we have the -1 on the nitrogen. Which is more electronegative, nitrogen or oxygen? Now we look at the periodic table, oxygen right there next to fluorine, second most electronegative element. Therefore, this is the most electronegative element, and we want the negative formal charge on the most electronegative element, so that one is no good. Okay? And that means this is the correct Lewis structure. Okay, one other thing about formal charges is formal charge always sums to equal the charge on the compound or polyatomic ion. Okay, so just bear that in mind. Formal charges always sum up to equal the charge. N2O has no charge on it. 0 plus -1 plus +1 is 0. That's the same for all three of these. -2 plus +1 plus +1 is 0. Okay, this video is running long, so I'm going to shut it off.